Good morning my dear student, and today we will see the osmosis and osmotic pressure, that is fourth colligative property. What is mean by osmosis? Osmosis is the spontaneous flow of the solvent molecule through the semi-permeable membrane from the pure solvent to the solution or from the dilute to the concentrated solution. Osmosis is the spontaneous flow of the solvent molecules through the semi-permeable membrane from a pure solvent to a solution or from the dilute solution to the concentrated solution. Now see in diagram, this diagram indicates the osmosis. Diagram shows the osmosis. In one compartment of the container there is a solvent, and the other compartment there is a solution is filled, and these two liquids are separated by the semi-permeable membrane. Okay. Now semi-permeable membrane allows only flow of the solvent molecules through it, and the direction of flow of solvent from the solvent compartment to the solution compartment is taking place. This process is called as the osmosis process, and this is a spontaneous process. Now, what is the semi-permeable membrane? Semi-permeable membrane is a thin sheet which allow the passage of only solvent molecule. Allow the passage of only solvent molecule. Through it. Semi-permeable membrane naturally available as well as we can synthesize in the lab. For example, the egg membrane. Egg membrane is a naturally available semi-permeable membrane. Then goat's bladder, cell membrane, also allows the flow of solvent only. These are the naturally available semi-permeable membranes. Artificial membranes semi-permeable membranes, for example calcium phosphate, copper ferrocyanide, then freshly prepared silicates of iron, cobalt nickel, etc. Freshly prepared silicates of iron, cobalt, nickel. These are the semi-permeable membrane. Okay. Now we know that if we mix the two solution of the different concentration, then after some times we get the homogeneous solution, and that process is called as the diffusion. Now there is a difference between the osmosis and diffusion. So what is the osmosis and diffusion? They are differ from each other. Okay. Osmosis takes place through the semi-permeable membrane, but the diffusion doesn't require any semi-permeable membrane here. Osmosis required the osmosis takes place through semi permeable membrane, while diffusion does not require semi permeable membrane. The homogeneous mixture is obtained as a result of diffusion, while the mixing is not possible in case of osmosis. No mixing of two solution or the solution and the solvent, but here the homogeneous mixture is obtained. Homogeneous mixture is obtained. Diffusion we can't prevent once it is start, but the osmosis we can stop. Osmosis can be stopped by applying pressure to the solution or the solution of higher concentration. Okay. Diffusion cannot be prevented. Diffusion cannot be prevented once it is started. This is the difference between the diffusion and the osmosis. Now see the osmotic pressure. While the movement of the solvent molecule from the low concentrated solution to the high concentrated solution or from the solvent compartment to the solution compartment, there is a hydrostatic pressure is created, and this pressure is called as the osmotic pressure. In general, if you have to stop the osmosis process, then the external pressure must be applied on the solution, okay, to stop the flow of the solvent into the solution through the semi-permeable membrane is termed as the osmotic pressure. The hydrostatic pressure developed as a result of the osmosis is a measure of the osmotic pressure of the solution, and it defined as the hydrostatic pressure builds up, can write the definition. Hydrostatic pressure built up on the solution which just stop the osmosis, and it is called as the osmotic pressure, and it is denoted by pi. It is denoted by pi. Then let's see the laws of osmotic pressure. Okay. Now before study the law of osmotic pressure, now see the types of solution. First is the isotonic solution. Isotonic type of the solution, isotonic solution. If the two or more solutions exerting the same osmotic pressure are called the isotonic solutions. The solutions, can write the definition, solutions having same osmotic pressure are called isotonic solution. And if we separate the solution of the same same osmotic pressure, then resultant there is a no flow of the solvent in either direction, that is the no flow of the solvent from one compartment to the another compartment. Second type of the solution is hypertonic solution. Hypertonic solution. A solution having a osmotic pressure higher than the another solution. A solution having osmotic pressure higher than that of the another solution. Another solution is said to be hypertonic with that solution. Okay. And next is the hypotonic solution. Hypotonic solution. A solution having osmotic pressure lower than that another solution. Lower than that of another solution. It's said to be hypotonic solution. Hypotonic solution. For example, we have the two solutions. One is a 0.05 molar sucrose solution, and second is the 0.1 molar urea solution. If the osmotic pressure of sucrose solution is less, then for example pi 1 is less than the pi 2, this sucrose solution and urea solution, then the sucrose solution we can call it as a hypotonic solution, and the urea solution we can call as a hypertonic solution. Because the osmotic pressure is greater than the sucrose solution and the osmotic pressure of the sucrose solution is less than the hypertonic solution, so it is a hypotonic and likewise. Then laws of osmotic pressure. Van't released that an analogy existence between the gases and solution provided the osmotic pressure of the solution is used in place of ordinary gas pressure. He showed that for solutions of the non-electrolytes the following laws holds good. First law of the osmosis is the Boyle-van't law. First law is Boyle-van't of law. Boyle-van't law. The law which the osmotic pressure states that the osmotic pressure of the solution is directly proportional to the concentration. Osmotic pressure, that is pi, is directly proportional to the concentration of the solution when the temperature is kept constant. When temperature is constant. Temperature is constant. If V liters of the solution containing the N moles of the solute, then it means concentration of solution is the number of moles of the solute in per the volume of solution. So, the pi is for 1 mole of solution. For 1 moles of solute, C is equal to 1 upon V. So, pi is directly proportional to the 1 pi V, and we can remove this proportionality sign by pi V is equal to constant. Pi V is equal to constant. This is our Boyle-van't law equation. Okay. Second law is Charles-van't law. Before studying the Charles-van't law, remember that the osmotic pressure of the solution containing the 1 mole of the solute particles per liter, that is 1 molar solution, for 1 molar solution at 0 degree Celsius temperature, the pi is equal, so that is osmotic pressure is equal to 22.4 atmospheric. Remember this value. You need this value while solving the JEE or NEET numericals. So remember. Then second law of the osmotic pressure is Charles-van't law. Charles van't law. It is also called as the Gay-Lussac's law, according to which the osmotic pressure of the dilute solution is directly proportional to the absolute temperature, when the concentration of solution is kept constant. When the concentration is constant, concentration of solution is constant. Then we can write the pi upon T is equal to constant at constant temperature, and this will be the equation of Charles-van't law. Okay. Then third law is Avogadro-van't law. Avogadro-van't of law. Law states that equal volumes of dilute solutions of the different solutes having the same temperature and osmotic pressure, that is for the isotonic solution. For isotonic solutions. Osmotic pressure is proportional with the number of moles of the solute. Here N is equal to number of moles of solute per liter of solution, per liter of solutions. This is a Avogadro-van't law, or third equation. The general equation for the dilute solution is obtained by the general equation for dilute solution is obtained by the combining of these all three equations. So we get the pi v is equals to nRT. Okay. As we know the ideal gas equation, PV is equal to nRT. Now in place of the pressure of the gas we have to put the osmotic pressure. So pi v is equal to nRT. This will be the general equation. And by using this equation we have to solve the further numericals. So see the problem, sample problem. Calculate the osmotic pressure of 0.01 molar solution of cane sugar at 300 Kelvin. R is constant and given. R is equal to 0.0821 liter atmosphere per degree per mole. The four options are given. So solve this. The givens are, given data में क्या दिया है, concentration here, given concentration is equal to 0.01 mole, that is 0.01 mole per liter. This is the concentration. R is given here 0.0. (0.0821 liter atmosphere per degree per mole, and T is equal to 300 Kelvin. So we have the formula, that is pi is equal to or the pi upon V is equal to nRT. So pi is equal to n upon V into RT, and n upon V is equal to the C. So pi is equal to CRT. Pi, it is osmotic pressure we have to calculate. Put up the value of concentration R and T. So we get the 0.01 molar into 0.0821 into temperature is 300 Kelvin. If we solve this, then 0.01 into 0.0821 into 300 will get the 0.2463 atmosphere. Osmotic pressure of the cane sugar solution is equal to 0.2463 atmosphere. So option B is correct here. Option B is correct. So ये था ऑस्मोटिक प्रेशर एंड उसके रिगार्ड द न्यूमेरिकल्स ये थे. चैप्टर ख़त्म होने के बाद हम मोर न्यूमेरिकल्स JEE और नीट के हिसाब से सॉल्व करेंगे। सो अगर आपको मेरा वीडियो पसंद आया है तो प्लीज़ शेयर कीजिए, लाइक कीजिए एंड सब्सक्राइब माय चैनल, प्लस प्रेस द बेल आइकन सो व्हेनेवर आई ऐड द न्यू वीडियो यू विल गेट द नोटिफिकेशन। थैंक यू।